Good day to you, my dear students in organic chemistry. Our last lesson for the semester is about chemistry of functional groups. In this session, we will be able to enumerate the types of functional groups and name the compound based on its functional group. Functional groups are the one responsible for most of the reactions of the parent compound. In particular, our focus is on oxygen-containing and nitrogen-containing compounds. And the most common is the alcohol. So an alcohol contains the hydroxyl functional group OH. Whenever you see a compound or a hydrocarbon with a functional group attached to it, the OH, that's an alcohol. So some common alcohols are shown below. So we have the methanol, the CH3 with OH, that is also called the methyl alcohol, the ethanol, that is C2H5 with OH as the functional group, that is ethanol or the ethyl alcohol. You have also the 2-propanol, ethylene glycol, and phenol. So those are alcohols because of the presence of the functional group OH. Ethyl alcohol or ethanol is by far the best known. It is produced biologically by the fermentation of sugar or starch. Methanol is highly toxic. Ingestion of only few milliliters can cause nausea and blindness. Ethanol intended for industrial use is often mixed with methanol to prevent people from drinking it. Ethanol containing methanol or other toxic substances is called denatured alcohol. Two other familiar aliphatic alcohols are propanol or isopropanol, commonly known as rubbing alcohol, and ethylene glycol, which is used as an anti-freeze. So naming alcohol. To determine if the compound is an alcohol, we need to look at the presence of the functional group OH. For example, CH4 or the methane has a structural formula of C bonded to 4 hydrogen atoms. But if one of that hydrogen atom is replaced by the OH, that becomes a methanol with the formula of CH3 rather, OH. So note, methanol is commercially called the methyl alcohol. Another example, the ethane. The ethane has a formula of C2H6. But when one of this hydrogen is replaced by an OH or the hydroxyl group OH, the ethane becomes ethanol. So the suffix OL, the NE or the E rather, is changed or replaced by the suffix OL. Okay, and the ethanol is commercially called ethyl alcohol. Starting from propane, we need to specify the number of carbon where the functional group OH is located. For example, in the propane, that is C3H8, but when one of the hydrogen in the propane is replaced by the hydroxyl OH, then it becomes an alcohol, and the name is 2-propanol. Why 2? Because the OH or the hydroxyl group OH is attached to the carbon 2. So propanol is commercially called an isopropyl alcohol. So it is the presence of the hydroxyl OH that makes a hydrocarbon an alcohol. Now let's move on to the ethers. Ethers contain the formula of R bonded to O and another R, where R is a hydrocarbon and O is the oxygen atom. Example, we have the CH3OCH3. That is skeletal formula of C with 3 hydrogen bonded to it, and bonded to the central atom oxygen. And on the other side, or on the opposite side, we also have another CH3. Since we have 2 CH3 on the opposite end of this hydrocarbon, we have 2 methyl hydrocarbon attached to the oxygen as the central atom. Then we use the prefix di, meaning 2. So we have the name dimethyl ether. Another example is the diethyl ether. You can see in the formula that we have 2 hydrocarbon ethyl on each side or on the opposite side, which are bonded to oxygen atom as the central atom. So since we have 2 ethyl, then we use the prefix di and then ethyl ether. Like alcohols, ethers are extremely flammable. When left standing in air, they have the tendency to slowly form explosive peroxides. Peroxides contain single bond to oxygen and another oxygen bonded to a hydrocarbon. So the simplest peroxide is hydrogen peroxide or H2O2. Diethyl ether, commonly known as ether, was used as an anesthetic for many years. It produces unconsciousness by depressing the activity of the central nervous system. The major disadvantages of diethyl ether are its irritating effects on the respiratory system and the occurrence of post-anesthetic nausea and vomiting. Now, let us proceed to aldehydes and ketones. Aldehydes contain at least 1 hydrocarbon atom bonded to the carbon in the carbonyl group. Let's take a look at the skeletal or the structural formula of an aldehydes. We have carbon, double bond to oxygen, and single bond to hydrogen atoms. This is a formaldehyde, or this compound is called formaldehyde or commonly known as formalin, which is used as preservatives for animal specimen and cadavers. Ketone. In a ketone, the carbon atom in the carbonyl group is bonded to the 2 hydrogen groups. You can see the carbon double bond to oxygen, and on the each side we have the hydrocarbon group, and that is the methyl group. So this ketone is called acetone. Ketones generally are less reactive than aldehydes. The simplest ketone is acetone, a pleasant-smelling liquid that is used mainly as a solvent for organic compounds and nail polish remover. And the last is the carboxylic acids. Under appropriate conditions, both alcohols and aldehydes can be oxidized to carboxylic acids, acids that contain the carboxylic COOH. These reactions occur so readily, in fact, that wine must be protected from atmospheric oxygen while in storage. Otherwise, it would soon turn to vinegar due to formation of acetic acid. So here are the list of the common carboxylic acid. We have the formic acid, we have the acetic acid, butyric acid, benzoic, glycine, oxalic acid, and the citric acid. Carboxylic acids are widely distributed in nature. They are found both in the plant and animal kingdoms. All protein molecules are made of amino acids, a special kind of carboxylic acid containing amino group, the NH2, and the carboxyl group, COOH. Well, we have so many organic compounds, but we will only focus on this most common functional groups. And I hope that you learned something from this lesson. So please be ready and prepare yourself for our final exam to be given on Saturday or this coming Saturday. Thank you for your time, and God bless to your final exam.